Hello my friends and welcome back to the YouTube channel for Galaxy Semiconductor. I'm Dan King, the Director of Media. Today we are joined again by our co-founder and CEO, Wes Smith. Thanks for joining us again.
Thank you for having me again, Dan.
If you guys missed it, Wes joined us last week where we talked about AI, artificial intelligence. We talked about machine learning. We talked about deep learning. We talked about how all this works together. And today we're going to take that baseline, the knowledge that Wes dropped on us, and we're going to actually talk about how this encapsulates itself into the industry of semiconductors. So Wes, with all that behind us and everything we learned last time, how does this play in the semiconductor industry? All of these deep learning, AI, machine learning.
Earlier in my career, I was working for a company in the silicon materials space as a factory process engineer. And we used a lot the Deming SPC tools. I had a Ford SPC slide rule. Anybody else have one of those?
I do.
You have a Ford SPC slide rule?
It was only given to me by a grandfather. That's the only reason why I have it, but I do have one.
We actually use them from time to time. We'd walk around on the factory with clipboards and write numbers down, and then we'd... Anyway, what we were doing was monitoring our results of squiggly lines, sort of like we have here. So we engineers like gathering data, and today it's very easy to chart using Excel or any of 100 different charting tools. We can put our data on a chart sort of like this one. And what we engineers like to do is we like to put straight lines around our squiggly lines. And whenever a squiggly line goes outside the straight line, we say that's an SPC rule breaker. Now I say that somewhat facetiously, but nevertheless, this process brought us a long way toward improved quality, improved reliability, really saved the US automotive industry at one point. But we reached a place in the semiconductor space not too long ago where this was no longer adequate. And the reason for that is that the volume of data just became overwhelming. And the volume of data growth began to outpace the ability of tools and systems to keep up with it. The other reason is there were too many false alarms. Engineers were spending all their time chasing one little data point out of control when really that probably didn't matter very much. So what we at Galaxy did is we went up a level. And so if you can imagine making a widget, a thing, in the case of our business, it might be a semiconductor materials wafer. So you have a process sort of like this in which we're measuring a lot of parameters and we're measuring them over time. It's a little bit like you could imagine making a cake. You've got your oven that's monitoring temperature over time, and you want to understand, well, did the oven behave the way I want it to, and therefore, is my cake going to be any good?
Before you eat it.
Before you eat it, right. So we take that set of data, and that equals one widget. In this case, I have on the screen here a semiconductor wafer. If we do it again, we'll get another wafer. If we do it 23 more times, we'll get a cassette of wafers. Now, what does this mean? So now we have all of these data, multi-dimensional data, and we have to try to figure out what's going on here. Well, we have an algorithm that takes this data and distills it down to a single number. And what that number represents is how far a particular batch, a particular cake, a particular batch of cookies deviated from what the machine has learned based on historical data about how the process should behave. So you could think of it as the further we get away from zero, the further we are from what we would expect that process to behave like.
And as you said in the last episode, that ties right into predictive analytics, right? That's essentially what this is, right?
Well, what we've learned is that this algorithm has predictive power. By that I mean that we loaded some data from one of our customers, and a pretty sizable amount of data. And because it was running in an offline fashion, not providing any feedback to the system, whatever was going to break, broke. And so we were very fortunate that we were able to say, hey, look, something broke. We could go back into our data and we could see substantial deviations. So normally numbers are around, say, 1 to 5, and we were getting numbers up around 80, 90, 100. And we could go back to our customer and say, hey, what happened here? And they told us, oh, look at that. 3 days later, we had an unplanned equipment failure.
So you were able to find this before it happened. Now this unplanned event, Tell me more about this. What does that even mean to people out there? What's the result of that? And what can you gain by catching it early?
So in our business, the hardware for manufacturing chips, electronic chips that go into literally everything, the hardware is typically very expensive. And some people may have heard on the news about the chip shortage. A lot of our customers are experiencing difficulties in meeting demand. And so an unplanned equipment downtime means that whatever time is lost is not spent making product, and therefore that product is not ultimately sold, and therefore that's lost time that will never be recovered. So an unplanned maintenance event, equipment downtime, can be very costly. We have some data that indicate well into 6 figures per day in a silicon materials fab, and I saw a statistic in Forbes magazine not too long ago that said a line down in an automotive plant can be as much as $24,000 per minute in cost. Oof. So clearly you want to prevent these things. If you can predict in advance when something is about to go wrong, you can bring that machine down in a controlled manner and spend a lot less time cleaning up. You don't have a fire drill trying to find parts, trying to find the right people to fix it. You can bring it down in a controlled manner. Scheduling has an opportunity to work around it. So the ROI of being able to predict unplanned equipment downtime is substantial.
$24,000 a minute?
That's a number that I didn't believe when I saw it either. But,
sounds like CEO pay to me. I'm sorry. I mean, what I meant to say was
not at Galaxy, no.
So if you're able to get this and you're able to predict it and you're able to plan around it, from the throughput perspective, the people that are waiting for cars, waiting for computers, all this chip shortage, how will it affect the end average Joe that is trying to go buy the newest laptop, wants the Tesla, wants this, and they have to wait a year? What does it mean if more manufacturing facilities were able to do this in that controlled manner?
Well, it's no secret that cars today are very complex machines with lots of electronic parts. And since we're in the semiconductor space, we understand the electronics piece of cars more than, say, the mechanical piece. But if we can alleviate shortage in one area, then that cascades through the supply chain and could eventually end up shortening those anticipated lead times. Maybe we shrink it from a year to 6 months. Because don't forget, you can hold up an entire Ford truck line, and this happened, for several weeks for lack of one chip. And so it's not hard to imagine when you start doing a little arithmetic that $24,000 a minute is a realistic number.
Now, Wes, with everything that you just explained and talked about is phenomenal. I can only imagine that there are going to be many business leaders that are going to be interested in this type of function.
Yeah, you're absolutely right, Dan. We're receiving a lot of inquiries from some big names in the industry. It's a very exciting time for us.
And that reminds me that next time, tune in, because you're going to be able to hear us talk about a very specific industry use case. And to make sure you don't miss it, go ahead and hit the subscribe button down below, hit the thumbs up button, leave a comment to us as to what you'd like to hear us talk about. Wes, it's been a pleasure again having you here. We'll see you guys next time.
Thank you.